coming back. Did you get my text, Maggie?
Yeah.
Okay.
Yeah.
Okay. We just wanted to make sure you were joining us because we missed you the last one.
Yeah. That was a time.
Was it?
Yeah.
Were you sick again or?
Not quite, but sort of. It was rough, and I'm sorry I missed it.
Well, we were worried about you. Oh, goodness. Okay. All right. Well, go ahead and start, Delene.
Yeah, should we start with prayer?
Yes.
Who would like to give it? Anyone volunteering?
I cry every time I do over math, so why don't you do that?
I'll give it.
This morning.
Heavenly Father, we're thankful for this opportunity to meet together for our pre-calculus class, and please bless us that we will have the Spirit and that our minds will be quickened so that we can understand new ideas and be able to see things in new perspectives as we discuss them together, and help us that we will have understanding. And we say since in Jesus Christ, amen.
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 Right.
Okay, so
Team discussion. Discuss and make sure each team member can define radians. You guys define radians?
I love this thing.
Oh, that's back.
You're back, yay!
I don't know what happened. I just couldn't hear anything. And I don't know
Do
if you can hear me.
Yeah, we can hear
Yeah, we
you.
can hear. Yeah.
Mm-hmm.
Okay. I don't know what was happening.
Okay, so can you define radians?
Radians?
Radians, yeah.
I think I know what they are, but like I don't know.
Okay, so if you take the unit circle, you've got like one unit like this way, and it's like all the way around is just one.
Yeah.
Like one radius. But a radian is that arc is of 1, 2. So if you divide it into a pi section, where both this section is 1 and the arc that it makes to the next angle is 1 as well, then that's 1 radian.
Yeah.
One
So it's
pi
got the
radian.
vertex.
Yeah, it's 1 pi radian, right? Yes, that's just 1, and then so it goes around, and if you go all the way around, you get like 2 pi radians because pi is 3.14. So basically, you could get almost a little bit more than 6 of those little wedges out of a whole circle, where each of these arcs was 1, 1, 1, 1, 1, 1, 1.
Which is why we have that nice little graph that we get to fill in.
Yeah.
Or those.
It's a little bit more than 6. It's like 6.2 of those little wedges. So we do the radians in terms of pi. We do like 1 pi radian, 2 pi radians, because that way we end up with 3.14 times that radian. But a radian is basically just 1 unit of this arc. So there's 3 of them in that 3 pi, I guess 3 radians in a half a circle. Like if you go all the way around, it's a pi radians, so it's 3.14 radians, basically. Does that make sense, or did I just make everyone more confused?
Nope.
Okay.
Maybe it's because I remember that.
So yeah, just think of it like 6 pieces of pie. 6 on a tiny bit, 6.2. So let's see, what's the next question? We've got to buzz right through these, huh? Next question, ensure that everyone has filled out the unit circle correctly. Has anyone filled out the unit circle correctly?
I know what page it's on in the book.
Well, there's a worksheet that you're supposed to fill out. This thing.
I know, I have it. I just haven't filled it out yet.
Cool. Well, it's not
Because
really.
I'm still going through the other stuff.
One cute way to do it is like these ones. My son taught me this. If you start with cosine, everything's over 2 basically in all 3 of these. You just put over 2, over 2, over 2, over 2. Then you do square root of 3, square root of 2, 1. Square root of 3, square root of 2, 1. So
Okay.
it's really easy. Like when you have it on the circle, it's actually kind of simple.
It is a lot easier than the way I used to figure it out.
Yeah. And the other side's the same way. Like 1, square root of 2, square root of 3, 1, square root of 2, square root of 3.
Okay.
And all the way over 2.
Okay. And you did your angles. Nice job.
Yeah.
Yours looks really nice.
Thank you.
Good job. No, I hadn't gotten to it, but I did find the page on the book. But now I'm going to look for that nice little look at the pattern.
Yeah, it's kind of handy. And the things that I always have trouble with, like I said, is the pi over 4, pi over 3. So it's pi over 6, pi over 4, pi over 3, pi over 2. Then we've got, what is that?
So it,
yeah. Sorry, pi over 6, 4, 3, 2. 2 pi over
so
3.
It follows the pattern.
Yeah.
Okay.
Weird looking at it backwards while I'm trying to point to it. So like, ew. But yeah, it does kind of follow a pattern.
Yeah, this is going to be very handy.
And Bill, it sounds like in this class, they'll let you do square root of 2 in the denominator, but a lot of classes don't let you do that. They want you to get that square root out of the denominator. So I'm just not doing that. So like they'll let you do 1 over square root of 2, but I'm used to rationalizing that to square root of 2 over 2. So where you just times both the denominator and the numerator by square root of 2.
Right.
In order to get that square root out of the denominator.
Okay.
Some people say that's just not a correct way to write a fraction.
Okay. But I see in the answer key what you're talking about, how they do let you do that.
Yeah. A lot of classes don't, but in this class, I guess it's fine.
Well, it might be fine right now.
Yeah, I know, right? And I'm sure it'll change next time.
I'm sure it will.
Like, what? That was cool last class. 3, discuss any vocabulary words that were not understood. Did you guys not understand any of the vocabulary? Any of them hard? No?
It just took me back to my geometry.
Yeah. Terminal side and all that. We all got that. Okay. We can move on to the extension problems. Find sine 4 pi over 3. Remember, it's cosine and then sine. Your x value is cosine, your y value is sine.
Okay, and I was just working on those.
So yeah,
super easy. You can just go down the line, like it's all just on the unit circle.
Yeah. Some of the negative ones were a little hard. You have to like count them out. Like, I don't know, what was it? Like negative 9 pi. It took me a little bit to be like 1 pi. 2 pi. Anyway, I don't know, I guess I'm not as bright as some. So yeah, 4 pi over 3, I got negative square root of 3 over 2. Because that's, 4 pi over 3 was where? It was 4 pi over 3 is like the 240 degrees. And since it's sine, it's the second one, it's the y value for that. So it's negative square root of 3 over 2.
Okay.
So then sine 7 pi. So you can go around and do 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, you put you over here. And the sign of it is 0, because that's the y value. And then 7 pi over 2. That one was a little tricky for me. This is pi over 2. 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. It's down here at 270. And it wanted the sign of that, so it's negative 1. But I kind of had to count that out, because I was like, how is 7 pi over 2 the same as 3 pi over 2? And I had to, like, I don't know. Because we use pi instead of tau, there's a math trend right now where they think pi is a retarded way of looking at trig.
Oh, really?
Because it takes the circle in, pi is basically a ratio of the diameter to the circumference, and we're always using radius to the circumference. So really you should use 2 pi, which would be, they've called it tau, to be the standard things, because then you wouldn't be having to constantly multiply things by 2 or 1/2 or all this other stuff that gets it confusing.
Okay.
So basically, like the circle would just be tau radians instead of 2 pi radians. So I like it better, but unfortunately math isn't like that right now. So when the math geeks change it, then do it that way. So yeah, 9 pi, negative 9 pi, we have to go the other direction. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi brings you over here at 180 degrees. And it's the cosine of it, so it's the first one, which is -1. Yeah, like I like my unit circle, like my cheat sheet. And then pi over 3. Pi over 3 is easy. It's just up here, isn't it? Yeah, here, pi over 3. And it was cosine, so it's the first value. It's 1/2.
Okay, the one in the book is not all complete, just so y'all know that.
Oh. So unit circle?
Yeah, the unit circle is not complete.
Well, anytime you look up unit circles, sometimes they'll give you these values, just in sine and cosine. Sometimes they'll give you the pi over 6, pi over 4, all that stuff. Sometimes it's just degrees.
Right.
Hard to find
Well,
one
this
that's
one's got it, but it's not accurate. Yeah.
Is mine wrong? More likely that I'm
Well, no, theirs is divided into 6. It's just not, it doesn't have the intermediate parts.
like this part, the 5 pi over 3 type stuff.
Right, it doesn't have those.
Yeah, not everyone does that. But
Yeah.
it's kind of handy to have if you make this chart. Like it's handy to have around for the rest of the unit.
Right.
That way you don't have to be constantly figuring out if it's over 3, over 4.
Oh yeah. I'm just looking at this going, darn it, it's not all of it.
Yeah, exactly. Okay, so which one are we on? F, 7 pi over 4? Yeah, I think we're at 7 pi over 4. That one was over here at 315 degrees. And it's just cosine of that, so it's square root of 2 over 2. The x value. Does somebody else want to do one of the other ones? Or
Well, that's what I was trying to figure out is exactly how it is that we're using our chart to make it work.
The chart just
So-
basically shows us how it is. So like, you just go to the chart for cosine, like pi over 3, and the cosine is the x value. The cosine pi over 3, the x value for that is 1/2.
I mean, you can sit and figure all these out, like what the cosine and sine of each of them is.
Right. Yeah. Okay. I'm just, like I said, I'm just trying to figure out how it all fits on the thing because I don't remember all of it because, we're talking more than 25 years ago. So I remember a lot, but I'm not remembering how to use it to get that. So that's why I was trying to fill in my thing and I was like, it doesn't match. So.
So do you need to see mine closer up again?
Yeah, just to get, okay, a little bit closer. Let me see if I can get it bigger. So like I said, I didn't get through everything that I was trying to. Is that square root 2 or square root 3?
Square root 2?
Yeah.
Square root 2. It goes 3, square root 3, square root 2, square root 1. I mean 1, sorry.
Did you try talking to the teacher to see if she would meet with us today?
Yeah, she said she could do it on Thursday, but not on Monday. So she's coming on Thursday's class.
Oh, sorry, Colleen. Oh, there you go.
I have a link to a filled out one if
Do
you want to use that.
Yeah,
What's the link?
Group?
You can just look up on Google. I just searched completed unit.
Yeah.
And
I think I just looked up unit circle chart.
Or even in
Okay.
embedded math.
Yeah.
If you go to embeddedmath.com at the bottom. they
That's
have
what I was
it.
thinking. Okay. Okay.
And they like up here in the positive and negative, I'm like not sure what they wanted in there, so I checked. And they basically wanted if sine was positive or sine was negative or cosine was positive and cosine was negative.
Okay.
Because like if you put one of these over the other, what would it be positive or negative? And I don't understand how that's helpful, so I just didn't even fill it in because I've never ever had to use that ever.
Well, when you're looking at that, I did see. I'm just trying to find where I saw it because I printed everything. When you are looking at your quadrants, I think that that's what it's looking at. Is are you in a positive quadrant, a negative quadrant, or
Yeah, but I mean, does that really help on a cheat sheet? Because it's kind of easy to figure out on your own.
yes and no. I mean, I don't
Like
know.
figuring out if tangent would be positive or if tangent would be negative is.
I guess if you're, yeah, but then it also helps you to name them, put them
Yeah.
together. Because it was on the PowerPoint that we were looking at. They put it in there as well.
Okay. Well,
So
then there's a little work to do to fill it out. Then.
What are we doing with number 1 then?
I think so. -5 pi over 4. I think is where we're at though. You have to go around the negative side.
Yeah.
So I have to do it like this. I go like 1/4 pi is like right here. -1/4 pi, sorry, is right there. 2/4, 3/4, 4/4, 5/4. So this is 5/4
okay.
negative because we're going the opposite direction, and I just have to go through like that because this doesn't list the negatives. So it's at like 135, and then you're doing sine of that, which would be square root of 2/2.
Yeah, and what I've figured out is you could just go to the regular place on the unit circle. So like if we go to 5 pi over 4 and then just switch the signs. Like this was -5 pi over 4.
Uh-huh.
You could just go to 5 pi over 4 on the unit circle and then take out, like, just flip the sign.
And that always works.
I think so.
Cool. I'll have to try that next time.
Because it's the same.
So you're doing are you doing the reciprocal relationships?
I don't know.
Was that on the vocabulary list?
It's in the trigonometry. It's on this one. I printed the stupid thing. It was driving me nuts. So it was in the PowerPoint.
Oh yeah.
Yeah.
That was super fun.
That's
PowerPoint.
what I'm studying. That's where I'm at. So that's what's in my brain.
Okay, yeah, I think we can move on to number 2. We've gotten through all of them. 19 pi over 6. We just wasn't so hard, I don't think, right?
If you're just counting around the circle.
Yeah. The fundamental theorem of trigonometry is an important identity. To have you better understand the theorem, answer the following questions as a team. Find sine pi over 3. You guys find that?
Wait, sorry, what was that question?
Supposed to find sine pi over 3.
Oh, yeah, I did that.
What'd you get, Rhett?
0.75 or 3/4.
You didn't just get an irrational over irrational?
We were finding. Sorry, what?
We're finding sorry, just like the last one where we found sine and cosine of the different things. We're just finding the sine of pi over 3. So.
Oh, yeah. Sorry, I was a step ahead.
All right.
God.
So you find sine pi over 3. Pi over 3 is right here.
Yeah.
Sine of it is square root of 3/2.
Yeah,
And then they want you to find the cosine of it, which is 1/2. And then you square both the 1/2 and the square root of 3/2 and add them together. And you get 1.
Yeah, I was sorry. I was
Yes.
saying the step where you square the.
Yeah.
Two.
Yeah, I'm sorry I didn't keep up with that. So you get 1 when you do that. And then the next thing it says to do. What did you find? Do you think this is true always, that you'll always get 1 when you squared this and add it to squared that?
Yeah.
Yes.
It's a unit circle, so every point on that outside equals 1. Like 1 away.
Mm-hmm. I know, it's basic Pythagorean theorem, right? A squared plus b
Right.
squared equals c squared.
Right.
You got the c squared's always going to be 1, then
Right.
you know that, yeah, it's always going to do that. So then it wants us to practice doing that a couple more times with pi over 4 and pi over 6. Pi over 4, square root of 2 over 2 squared is 2 over 4 plus 2 over 4. That's just 1/2 plus 1/2 is 1. Pi over 6 is square root of 3 over 2, which squares to be 3 over 4. 1/2 squares to be 1/4, so 3/4 plus 1/4 is 1 as well. And we basically said why we think it works this way, and that it happens the same. Okay.
Mhm.
Okay, number 3. In preparation for this Google Hangout, you previewed PowerPoint that explained how sine and cosine values for each angle was found. One thing we hoped you noticed was that you used the Pythagorean theorem each time. Because it's a unit circle, the hypotenuse will always be 1. Thus, using the Pythagorean theorem, x squared plus y squared equals 1. Since the cosine function is the x value and the sine function is the y value, we can do substitution cosine squared x and sine squared x equals 1, which is the fundamental theorem of trigonometry, or also known as the Pythagorean identity. Please note that the square is written in between and not at the end. So you can't write x squared. It's cosine squared x. The first one squares the value of cosine x. The second one squares just the value of x. So there's no question there. Number 4, refer to the chapter in your book corresponding to lesson 2 to discuss the formula of the motion of a spring and go through the practice problem. That's page 58 for those that want to go to it.
Yep.
58.
I'm already there.
Yeah, it would have been really nice if they put that in the instructions, but I had to like search it.
Or they just put the problem in the instructions.
Yeah.
Do we all need to turn to it, or?
Yeah, 358.
Okay.
Kind of a little tricky to understand. It gets a little
Yeah, no.
in the weeds because they're using like omega and crap.
And you're looking at example 1? Is there an example 1? I'm not, okay, hang on. I have to make it bigger so I can see.
Let's just do the example.
Which example number? Oh, there it is.
I think it's
see
the one from the spring problem. Yeah. It gives you a formula for finding the spring stuff.
Right.
And it makes it all kinds of scary looking, but it's really not, because that omega they make it a constant of 1. So it kind of becomes something that you don't really have to work with much.
But there is an example of that problem on the next page. It's example number 8.
You said 358?
Yeah, 358. And 359 is where it goes on to.
Okay.
Yeah, and there's an actual example of it, to an equation to do.
Yeah, example
Problem
8
with
is what I think we're supposed to work through.
Right. Okay. That's what I was thinking.
I don't know if it's like example 8 that they want or the try this one. Because example 8 kind of gives us the answer. So we can do either.
I think, I don't know. I always find both of them very helpful.
So what one are we doing?
Which one do you want, Brett? I'll let you decide.
Oh, geez, I don't care.
Okay,
I'll pick up example 7 and 8.
let's start with the first one. So
Number 7.
let's see, since upward velocity is negative, and locations below the equilibrium are positive, we have the velocity equals -3. And the location is 2 because it's below the equilibrium. And they set the omega as 1.
You're doing example 7?
Example 8.
Oh, okay.
Okay, we got all confused here.
Are we on 7? You guys want to do 7?
We'll do 8. You're already there.
Okay.
Okay. Ugh.
So they put the value of the velocity is -3. So it's -3 sine t plus 2 cosine t. And they put the time as 2 seconds. It ends up being -3 sine 2 and 2 cosine 2. And then that's something you can just plug into your calculator.
So how did we know to put like sine and cosine in there for that?
It's the parent formula that they give us on the other page.
Oh, okay.
I think I have this. I still had my thing set in degrees, not radians. You have to do it in radians.
Your calculator?
Yeah.
Okay, so how do you switch them back and forth, just so I know, because I haven't been able to do it yet.
Do you have like a T189 or whatever?
I have a TI-89 or 84.
Okay. That one, I believe you go to the menu. Sorry, I don't have my son's with me. I'm having to use like an online one.
Right. Okay.
I'm refusing to buy a calculator. Rhett, can you show her the
How do you switch between them?
On what?
between
Between
radians and
radians.
degrees? There's a menu function, but I can't remember what buttons it is on this guide. 80.
I don't know. I'm using this kind of calculator.
Oh, so a scientific one.
I have one of those too. But I really like this one. It's cool. I got it for my birthday, so I'm happy about it.
I remember it was relatively easy. Unless I have it to look at, it's hard for me to remember what.
It's okay. I'll figure it out. My daughter's boyfriend is handy to have around.
Yeah.
Yeah.
Yeah, it's super easy to do, but basically with that one you get -3.6.
Okay. Got it.
Good.
Like that.
So how did you enter it in your calculator?
I wrote it as is. I did it on my.
Can you read that?
You have a sign button.
I do.
Oh, do I need to change it? I need to change it from radians to degrees. Is that what?
No, you need to have it in radians.
Yeah, it's in radians.
Okay, that's where it is.
Did that help, Rhett?
Yeah, I just didn't have it in radians, so I'll change.
Okay. Yes, my nice little sine, cosine, and tangent button works really well.
Okay, I got it. Is that all we have to do for today?
Yep, that's it.
Mm-hmm.
Okay.
I know, right?
Nice.
That was easy.
I think it was mostly, I think she gave us an easy assignment because the understanding it can be hard for some people.
Hmm.
They haven't ever done anything.
Well, that was kind of a nice change that I actually had more grasp of it.
Well, there's a lot of PowerPoints and the homework is long and there's plenty
Yeah,
of
well, and I have to tell you, I appreciate the PowerPoints because the reality is if I can go through it and feel like I'm being taught the information, then I can have time to remember things instead of just being thrown into homework and going, I don't remember this. Where'd this come from? So,
and having to listen to those technical
well, yeah. And so anyway, so it's kind of nice to have it actually be taught to me first instead of having to go find the information to be taught.
Hmm.
Yeah.
So,
I feel like this class is definitely confusing. Well, like trying to figure out what stuff goes with which and where to find where to learn and
right.
Right.
I mean, I do find that if I read the chapter first, I tend to do better. But with us meeting on Mondays, I don't have that opportunity because
Right.
I am keeping Sunday sacred. And so it's really hard not to do that. And if I don't get done early enough on Saturday, there's no way I get to it before, 7:30, 8:30 on Monday morning.
I find text doesn't help me as much. I like working through problems and then trying to figure out where the holes are.
Usually by the time I go through all the homework, I feel like I understand it well enough, but it takes me forever to get through the homework. So
Right.
Yeah, I know, because I have to help me solve.
every
Yes.
single time.
Yeah.
Yeah.
Or show me an example.
Yeah.
Okay. No, show me again. Show me again. Yeah, and it's really bad when it's every problem. Although last week I didn't have that happening, which was really nice.
Mhm.
That was a little bit faster to get through it. But
Yep.
and then what I don't like is when they don't skip a step, they do a step, but they don't explain it.
Yeah.
And it's like, wait a minute, no, I write every step.
yeah, all of a sudden they
Mhm.
just have all these new numbers and you're like, how did they get those?
Right. It's like I'm sure that they simplified somehow, but I'm not logically seeing it. I need to see you do the simplification step. So, yeah. So that's been nice. Been nice to do that. So, all right. Well, you guys have a good day
You too.
and
Yeah.
have a little more time. I guess, right, you get more time today than normal.
Uh-huh. Well, my roommate just came in and said he's going to the store and I need to go get some food, so it worked out perfectly.
All right. Well, have fun at the store. See you guys on Thursday.
Bye, guys.
Bye.